This is Larry. This is April 5th, day 5 of the 30-day Leetcode challenge. Uh, yeah, okay, let's get into it without further ado. Okay, what's today's poem? Best time to buy and sell stock too. Also a poem that's already been on Leetcode. Don't remember it though. So you have an array for which the ith element is the price of a given stock on day I. Design an algorithm to find the maximum profit. You may complete as many transactions as you like, i.e. buy one and sell one of the stock multiple times. You may not engage in multiple transactions at the same time. You must sell the stock before buying again. Okay. Um, you have an array. Buy on day 2 and then sell on day 3. Okay. Buy on day 4. So day 4. Oh. And then sell on day 5. Okay. Hmm. Okay. Um, so I don't actually remember, like which is good in a good way. I don't remember solutions, but it seems like there is some sort of greedy, and because you can buy, you could you could sell, you could treat at every step of the way as if you bought it on the previously at the lowest price, and then when you go down you can treat it like you already sold it. Uh, yeah, something like that. So, okay. Let's just say total profit is 0, returns profit. So this, for me, feels a little ad hoc-y. Um, maybe, I mean, I guess it depends on N as well. You could maybe do dynamic programming if you really want to, but, and maybe we'll get to that. I actually don't, yeah, but I think for now, I think it's okay. So now for price and prices, say last port is you go to, let's just say infinity then, right? Uh, so if price is less than last port, then let's just pretend we port it now instead. So otherwise, um, profit is equal to, let's say we made a profit, so let's sell it, and then pretend we bought it, or we potentially bought it at the current price. Yeah, something like that. I have a typo. Oh, bought and bought. I thought it was blazing fast earlier, but today it's not. Hmm. So if oh, I forgot to oop, poop typo. Also, might as well while it's loading, paste in some test cases. Um, hmm. Okay, seems like, for example, we want to do this anyway, and then if price is bigger than last four, then we just add it, right? Um, no. Hmm. So, so, and now it's 1. I know it's something silly. Why is it just 0? Do I have? Oh, I have a typo again. Okay. Eh, English is hard. And unlike using a language that, that's the one thing that's a little tricky sometimes with Python, for me anyway, is that because they don't have type safety, when you do assignments like that, it could be wrong. But yeah, let's add a couple more test cases. Let's spend some time. Oops. Let's just say n is equal to 1. I mean, I think this is already done, just one increment. Let's do negative numbers. Could be negative numbers, right? I guess it doesn't really say. I guess in theory, in the real life, you can't, or like there's no real negative numbers in real life. Uh, well, I guess depending on how you want to count shorting, but not really. But okay, so let's submit it and let's take a look. Cool. Yeah. So let me explain this form a little bit. I think I hand waved a little bit because I don't remember quite well. But yeah, but the reason why I chose the last port as the previous price, and obviously now that this is correct, we can rewrite this in a cleaner way. Um, but basically, the idea is that we only so every step of the way we assume that so there are only a couple of let me start over a little bit. So there are only a couple of possibilities. Let's say you have like an increasing sequence, right? Um, the thing to note is that if you buy here and then sell here and then plus this, so then you have a delta of, so in this case in a rising sequence, what is it? Oh man, this auto indenting thing is annoying me. So basically 2 minus 1, so then you have the sum of this sequence, um, which maybe I wrote it backwards, which if you reverse it is 5 minus 4 plus is 4 minus 3 plus 3 minus 2 plus 2 minus 1. And also, obviously, it works for any numbers. But you could see that in this case, these cancels out, these cancel out, and these cancel out, right? So then, because all these things cancel out, this is equal to this, which when you think about it, what it's saying is that if you have a rising sequence, it doesn't matter if you sell it and then we buy it every step of the way, or you just hold it from the beginning to the end, right? So in a way, you could kind of merge them together, uh, and I do a reverse merge, if you will, so, where I just look at it allows me to do consecutive ones, and then now look at the other way is let's say going down. I guess it's like a mountain or something. Um, Going down, if you bought it at 5, so that now we could ignore the beginning because let's say we already sold optimally. Um, so for 7.5, you're not ever going to sell any of these. But so then let's pretend that here you already sold at 5, and looking at 4, you're like, okay, let me buy at 4 instead, right? Because I would never buy in 5 because I wouldn't make money on 5. Same thing for 4. You wouldn't buy at 4 because you wouldn't make money on 4, and then so forth, and then until you get to like say another number, let's say 7, right? Well, in this case, um, oh yeah, you make money here, but you make more money if it gets lower, right? So then using that kind of logic is why this thing kind of works, is that we just assume that the last port would be like if it's increasing, then we just take the lowest one, and if it's um, if it's decreasing, then you wouldn't, like between two adjacent numbers, if it's decreasing, then you would not, you would always buy it at the lower one anyway, and then using that, you keep on going, stepping down, and that's how I kind of thought about this problem and going back. Um, you could also probably do dynamic programming if you're really having fun with it, but that's how I would think about it. Anyway, yeah, so this one also a known problem, even though I haven't done it in a while. So it's a good practice to kind of do that, flex that muscle, especially since I consider this a little bit of ad hoc-y, mathy, arithmetic-y problem. But yeah, well, I think this is actually a better representation of an interesting problem than the other one. It's not about a trick. It's about doing playing around with these formulas and special cases, even though it's ad hoc, so it's a little bit always going to be a little bit tricky, at least for me. But yeah, it's an interview question. Um, yeah, it's an interview question. I think it's okay. It's a little tricky to prove the math. It's a little bit too mathy for me as a problem that I might give. Um, but I could definitely see something like this, and if nothing else, you could step through it one by one. Like, okay, what is the way to do it by brute force? How do you do it with brute force? What is the length? How do you make optimizations? And these are things that would be interesting anyway. My only concern about a problem like this in general is that if you have seen it before, it doesn't give me enough of a signal. I mean, that's the case with a lot of problems in general, but this is even more so because it's just like a for loop, right? So you can't even talk about like, oh, how would you break the code down? How would you like structure things out? How do you make the code cleaner and stuff like that? Which, even with like something so simple as depth first search or breadth first search, you could talk about it or different constraints and base cases and so forth. But yeah, anyway, that's what I have for this problem. See you out again tomorrow. Bye bye.